Alrighty, in lesson 97, we're going to talk a little bit about advanced substitution. So typically, let's just jump into 97.1. When we have a system of equations that looks something like this, let me write these right here for you. I'll let you read them instead of reading them to you because I know that you guys probably find that annoying because I would. So typically when you have a situation like this where we have a system of equations where we have a positive and a negative already, typically we would multiply by the opposite coefficient and get a positive 6y, negative 6y, and use elimination to solve. But in this lesson, we want to illustrate how substitution can be used instead of elimination. We've already discussed that, but we haven't really shown exactly how to do that with these more advanced systems of equations. Elimination just seems to be a little bit easier, but it is possible. And you always get the same answer as if you had used elimination. So I'm going to move this over here, and we're going to find a substitution value for y from this first equation. So I'm going to subtract 3x from both sides. That leaves 2y is equal to negative 3 minus 3x. I'm going to divide both sides by 2, which leaves negative 3 minus 3x all over 2. There's my value for y that I'm going to substitute into this equation. So 4x minus 3 times negative 3 minus 3x over 2 is equal to 13. So I just took this value for y that we got from this original equation and substituted in for the y value here. So now what I want to do is get rid of this denominator. I want to put everything back into a numerator or a whole number status. So I'm just going to multiply everything in the equation times 2. And I'm going to write that here, including our result, or our, I guess that would be sum. So now let's do the multiplication. 2 times 4x is 8x. And when I multiply here, the 2's are going to cancel. Negative 3 times negative 3 is going to be a positive 9. Negative 3 times negative 3x is going to be a positive 9x. And 2 times 13 is going to give me 26. Okay, so when I add these together, I'm going to subtract 9 from both sides, and I'm going to get 17x is equal to 17. X is going to be equal to 1. So there's my value for x. So I can go ahead and I can substitute that back into this original equation here. 3 times x will be 3 plus 2y is equal to negative 3, because 3 times 1 is still 3. Subtract 3 from both sides, I get 2y is equal to negative 6. Divide both sides by 2, y is equal to negative 3. So my solution set is 1 and negative 3 for my x and my y values. So as you see, you can solve using substitution instead of elimination on these more complex problems. Why don't we try another one? All right, we are going to, I'm going to pause and clear the page and write the second one out for you. All right, in 97.2, these are our 2 equations in this system. So let's solve for x this time. We solved for y last time. We'll do x this time. So we're going to add the y value to both sides. That gives us 5x is equal to 9 plus 3y. When we divide both sides by 5, we get that x is equal to 9 plus 3y all over 5. Now we have an x value that we can substitute into our second equation. So 2 times 9 plus 3y over 5 minus 4y is equal to negative 2. We're going to multiply everything by 5 to get rid of it. So 2 times 5 times 9 plus 3y over 5 minus 4y times 5 equals negative 2 times 5. These two 5's cancel, and we are left with 18 plus 6y minus 20y is equal to negative 10. When we combine these, we get that 18 and negative 14y is equal to negative 10. We're going to subtract 18 from both sides, and we get negative 14y is equal to negative 28. When we divide both sides by negative 14, we find that y is equal to 2. So our first value in our solution set is the y value of 2. Now when we substitute that back in to our original equation, 5x minus 3 times 2 equals 9. 5x minus 6 equals 9. We add 6 to both sides. 5x is equal to 15. We find that x is equal to 3. So 3 would be the x value of the solution set for 97.2. And that is all we have for lesson 97. So you can see that you truly can use elimination or substitution to solve for a system of equations with two linear equations within it. And that's all we have for lesson 97. And I will see you in lesson 98.